Chapter 6, problem number 21. A 6,200 kilogram satellite is in circular orbit that has a radius of 3.3 times 10 to the 7th meters. A net external force must act on the satellite to make it change to a circular orbit that has a radius of 7 times 10 to the 6 meters. What work must the net external force do? So we're looking for the net work to do this. So that's equal to the change in the kinetic energy of the satellite going from here to there. Okay, where this is the original orbital radius and this is the final orbital radius. So let's find an expression for the speed of the satellite in each one of these orbits. And knowing the mass of the satellite, we can find then the change in kinetic energy of the satellite going from the outer to the inner orbit. So the speed of the satellite in the outer orbit, we can use Newton's universal law of gravitation. And the force of gravity provides a necessary centripetal force. So I can set that equal to the mass of the satellite times the speed of the satellite squared all over the orbital radius, which is RO. That's equal to G ms me all over RO squared. The mass of the satellite appears on both sides. So now we can solve for the speed of the satellite. That's the square root of G me all over RO. So that's the speed out here. Okay, so we'll call that VSO for the outer orbit. The inner orbit then, or I should say, that's the original orbit, not the outer orbit, and then F stands for the final orbit, which is the inner orbit. So that would be equal to the square root of G me over RF, where F stands for the final orbit. So knowing this and this, now we can find the change in kinetic energy. So that's 1/2 the mass of the satellite times the final speed of the satellite squared minus 1/2 the mass of the satellite times the original speed of the satellite squared. So we have here G me over RF minus G me over RO. Factoring out a G me, we have ms G me all over 2 times 1 over RF minus 1 over RO. So substituting in the values, that will give you the net work. Okay, so the mass of the satellite is given as 6,200 kilograms. G is 6.67 times 10 to the negative 11th. Mass of the Earth is 6 times 10 to the 24th kilograms. RF is given as 7 times 10 to the 6 meters. And RO is given as 3.3 times 10 to the 7th meters. All right, so let's see what we get for the net work.